from you in the DSN way. So I would like to remind us the aim of this conference. Let us not forget that the aim of this conference is to help you become a machine learning expert. This conference will enhance your skills by offering you the comprehensive knowledge and the required hands-on experience on different cloud-based ML tools. You will be exposed to solving real-time industry-based projects without needing any complex coding expertise. You'll also be prepared for the future of work ahead of you, knowing that there are diverse opportunities and high demand for people with machine learning skills. I hope we are all prepared for today. Thank you. So let's get started. So this conference is brought to you by Data Scientists Network. We are formerly known as Data Science Nigeria. For the sake of those who don't know DSN, I'll give a brief introduction about Data Scientists Network. I'll talk about milestones and recognition shortly. So at DSN, one minute, please. So at DSN, we have the commitment to raise 1 million AI talent and to build AI solutions that improve the quality of life and well-being of 2 billion people in emerging markets. Now, how do we achieve this? We achieve this by focusing on 3 core areas, and the areas are community for learning and research, product development for social impact, and partnership for solution delivery. Now, that is not all about DSN. We have some milestones and some recognitions that are not locally alone, that are international also. Some of firstly, DSN has been recognized at the Deep Learning Indaba in 2019. We won the Matai Impact Award. We were recognized as the first #1 artificial intelligence learning community and solution delivery network in Africa. Also, DSN won the Best Academic Poster at the 21st edition of the Global Economic and Computation Conference in 2020. We were also recognized as the only finalist at the at the 2021 X Prize competition. So we can see that DSN has gone far. So DSN has released the first sorry, 1 minute, please. I've also released the first artificial intelligence and Python book for elementary students and beginners in Africa. So if you have children that are interested in artificial intelligence, they are interested in tech, this is a good book for them to work with. So another thing is that the DSN has a dedicated hub that is located at Yaba in Lagos. If you are interested in working in a serene environment that is comfortable and is very affordable, you can come to our hub. You can visit our website to book for this. And to achieve our goal of raising 1 million AI talent and improve the quality of life and well-being of 2 billion people in emerging markets, we have a business model that focuses on career tech, fintech, retail tech, health tech, platform tech, and health tech, and so on and so forth. So that is not all about DSN. DSN also has a Dsn Ai Startup Lab for startups. These are some of the startups we have worked with in the past. So we did not walk all through this journey alone ourselves. We are supported by a very rich world-class advisory board. They are working through the journey with us. So if you really want to know more about DSN and you want to enjoy all these privileges, I enjoy you to join the community of our professionals. You can scan the QR code on the screen or use the URL that will be provided in the chat room now. So if you are just joining us, you are welcome again. This is DSN and we are in No Code AI conference. Today is day 3. And before I continue, our topic for today is no code machine learning using Amazon AWS SageMaker Canvas. So this is a topic our speaker will be speaking to today. And I want to confirm if the speaker is on the call. David, are you on the call, please? David?
Yeah, hello, can you hear me? Yes, I'm on the call.
Okay, thank you, David. So before I hand over to David, let me quickly introduce David. So David Akonji is the Impact Network and Community Lead at DSN. He is an experienced, analytical, business-driven minded data scientist with expertise in business analysis, data analysis, geospatial analysis, project management, database management, and advanced monitoring and evaluation analytics. One of his primary tools is achieving success in using the agile methodology in everyday business, which enables him to streamline the process, substantially enhance their administrative duties and reporting method, and implementing analytical tools. With your favorite emojis, I want you to welcome David. David, are you ready for us? Hello, David.
All right. Okay, thank you. Please, can you confirm?
Over to you now.
Yeah, can you hear me? Hello, can you hear me?
Yes, I can hear you, David.
All right. Thank you so much. Thanks so much, everyone. I can see a lot of excitement on the chat. It's another day again to create more impact, to bring learning at very to the lower level, whereby people can understand and be able to make use of AI across every field of their choice, or apply AI in any industry of their choice. So I can see that we have a lot of great people on the call already. So kindly use any emoji of your choice. So let me confirm if you have been part of the training from day 1, which is Monday, where we are taught how to build a chatbot. And yesterday we learned how to use NVIDIA Cloud toolkits. So let me have one of the key takeaways that you've had in the last couple of days that we started this AI no code conference. So let me see one of your key takeaways. Can you drop it on the chat while I share my screen? Okay, wow. So a lot. I can see that a lot of us have learned a lot in just a little day that we have spent on the conference. So that's really impressive. So as Toby Loba, as she's rightly said, so I will be. Let me share my screen here. Okay, Toby, can you confirm if you can see my screen?
It's not up yet.
Okay.
It's up now.
All right, thank you very much. Okay. All right. So today, all we are going to be, I think that the agenda of our lesson today, we are going to be talking. So for the case for some of the learners who are just joining us for the first time, or who doesn't have any prior understanding, or who doesn't have good knowledge of what is machine learning is, and we try to take some little introduction to that. Just going to be very little, and then I will also some terminology that's being used in machine learning model, especially the one that is particular to this particular training. And then I'm going to introduce you to AWS, and also to how the interface look like, and then we are going to be making some predictions and show you how to make some predictions with most especially on finance, people who are working in the bank industry. How can you make a prediction to know if the bank history or proof? We are going to be doing some spam SMA detection. Hello, can you hear me?
Yes, I can hear you now, but you were breaking earlier.
All right. Thanks so much. So we are going to be looking at some spam detection and then make some prediction on customer churn and wide quality prediction. As we all know, this particular conference, we are not going to be doing we are not going to be going to too details of how to do some implementation or do some work, but we want to show you some of the things that we can even do without writing a code. So that is the meaning of the AI circus that we are running, to show us some of the things that no code tools can perform, which I will be diving into now. So as we all know, machine learning okay. All right, so for the purpose of people who doesn't know about machine learning, so as you can see from my screen, machine learning is a modern innovation that has enhanced many industry and professional and process, who has helped them in their day-to-day activities. And also, so in short, it generally a name given to an extensive collection of algorithms that are used to allow a computer to identify patterns from the past data and use those patterns to predict the future results. So the field of machine learning is considered to be a subset, or let's say the subset field of a field called artificial intelligence, which I'm very sure a lot of us are well acquainted to. So machine learning or AI is being used in our day-to-day life. So example of this is when we are talking about your favorite streaming device. You know, some of us watch Netflix, we stream on Spotify. All these platforms are being run by machine learning. Another thing is that we have some of us want to ask a question now. You use a search engine. You go to your Google to search something on Google. So search engine use machine learning to clarify and optimize your search results. So if you go to my Google, you will see that what you ask, Google could provide the answer for you. So that is machine learning as well. So all our social media like Facebook.
Hello, David, are you still with us? Hello, David. I think we lost him there. Give him 1 minute. Okay, he's back. Hello, David, are you here now?
Yes. Sorry, I don't know that my network has broken. But you can hear me correctly now, right?
Yes, I can hear you clearly now.
All right, so what I'm saying is that machine learning or AI is being used in our day-to-day life. So an example of this is our favorite streaming device like Netflix. We stream on Spotify. All of these tools are being run by machine learning. So another thing is the search engine, the Google search engine that we use, or Bing. If you use Bing, Microsoft Bing, they use machine learning to clarify and optimize your search results. To optimize your search results. GPS as well, like all the Google map that we are using, they are part of the which optimize our routes. Like if you are going to a location, they tell you the fastest route, they tell you the time it will take before you get to a particular location. So all of this is machine learning. And also when we are talking about, let's say, voice, when we talk about voice, an example is the Alexa, Siri. They use machine learning to operate as well. So you can see that we have a lot of machine learning around us. So there is a lot of machine learning algorithms which run every single second, which I'm very sure we all know about them around us. So we just talk about and then machine learning is also, a lot of companies currently use machine learning. Some of them, we have Google, Amazon, Netflix, Microsoft, IBM. They all use machine learning a lot. So now, how does this machine learning work? So what is the process in the machine learning? So the process is very simple. First, we identify the relevant data sets and prepare them for analysis in machine learning. So first of all, identify the relevant data set and prepare them for analysis. Then secondly, what we do is the second step is we choose the type of machine learning algorithm to use, and then they build an analytical model based on the choosing algorithm. So we choose the type of machine learning algorithm to be used. Then we build on that model based on the algorithm that has been selected. So the next thing is after that, the model is trained on the test data set, and that is reversed as it is needed. So the fourth thing now is if the model is run the model is trained on the test data sets, and that is revised as needed. So also the model is run to generate score and other findings, and loop doesn't end. So this process is run from identifying the choosing of the type of the machine learning model, then building of the analysis based on the model, then you train your data on the test data set, then you run the model to generate scores and other findings. So that's how the process works. So in the course of the training, we are going to be talking about what happened to this new data when it comes in. So machine learning process is fairly simple. With these 5 steps that I've shown to you, you know that it's not heavily complex. So this is just the basis of machine learning. So I'm sure you are very well aware of it now. So some important terminology in working with machine learning. So if you look at this, is a result of one of the machine learning model. What we are seeing on the screen, the result of one of the machine learning model it saw the F1, accuracy, precision, recall, AUC. So what is the meaning of one of these terminology when you see them in your machine learning model? So let me show you. So when you see accuracy, so accuracy is the most intuitive performance measure, and it's simply the ratio of correctly predicted observation to the total observation. So when you predict your model or that machine learning model, and that particular model, you have the model predicts it. This you can see the percentage of what the model predicts correctly is what we are talking about, the accuracy. So the F1 score is the weighted average of precision and recall. So the precision is the ratio of the positive predicted value. If you look at it, the positive predicted value, what the model does very right, and over the whole outcome. So and recall as well. So this is a formula for recall as well when you are working with your machine learning model. So another thing that we have in machine learning terminology is that when we talk about correlation matching. So it's just a simple table that displays the correlation coordinate for different tables. So and then we have ROC, this is receiver operating characteristic curve. So this displays the probability graph for the performance of your model classification by using a trench approach. So we are going to be seeing all of this as we dive into today's session. So I'll be sharing my screen and walk you through some of this now. Let me. So this is the let me drop this URL to the chat. So this URL you are looking at.
Yes,
David, you are muted. Okay. We can hear you.
Yes, I know. Okay, thank you. So now we are going to dive into AWS, where we are going to be the platform that we are going to be using to train our model. So this is AWS mentioned. So it has the AI platform that we want to use to train our model. So they run different types of services, which is what you can explore when you go into their website. So one of the things, if you don't have accounts yet, so what you need to do, you need to like I already have an account, so I might not need to click on to sign in. I will just click on sign in if you already have an account, but if you don't have an account, you just need to click on sign up. So the signing up to the platform is pretty simple. So let me show you one of the steps of signing up. So you can see now, if you don't have account before, you create an Azure account here. So this is what you need to do. You click on create an AWS account. So when that is loaded, you follow you follow all the instructions that we have here. You provide your email. Then after that is done, you provide the account name that you want to be using. Then you click on verify your email. Then when your email is verified, then it will take you to this page. It will take you to this particular page. It will take you to this particular page that we are here. it will take you to when you have signed successfully, it will take you to this particular page. So I already signed it, so I might not need to go through that process again. So this is what we have. So we take you to this page when you are done with your signing in. So I will not go through that process now due to the time limit that we have. But so I will click on signing into the console. So when you sign in into the console, so you see Amazon SageMaker, then you click on Amazon SageMaker. So what we are going to be using for this, so on the Amazon SageMaker, we have different types of things that you can do for machine learning introduction. You see, these are the workflow for building your machine learning model. Label, you set up and manage your, this is when you set up your data by cleaning your data. You build your data, then you train, you fine-tune, you deploy. So after you are done with everything, you deploy and then you work around your data again. So these are just so you can go through this when you're signing from your own site, but the steps is pretty simple. So, but when you want to start your work, you click on Canva. So we want to be working on Canva. You click on Canva. So we wait for it to be loaded. So this is it here. So it has loaded. So we click on Launch SageMaker Canva. So when you click that, so it shows that you want to launch the app. So this is it here. It has shown that you want to launch the app. Then click on Launch. You click on Canvas. So it will launch the page for us. So we can see that the page has opened. So we have a lot of data that we are going to be using for our machine learning project today. So one of them is we are going to be working on wine quality data. We are going to be working on spam SMS detection. We are going to be working on banknotes, and we have a lot of sample data that the platform has provided for us. But a quick one, I will quickly show us how to do a lot of work on this particular page. So let's go to Cargo. Let's get our data online. There are different data that you can search online. So to show you how applicable this particular platform can work for our machine learning model. So let's check spam SMS Cargo. So you see this particular spam SMS, this particular data here that we have on Cargo, it shows this particular data here is what we are going to be using. It's going to be one of the data sets that we are going to be using for this analysis. So you can see the content. This SMS spam collection is a set of SMS tag messages that have been collected for SMS spam research. It contains one set of SMS message in English of 5,574 messages tagged according to being legitimate or spam. So these are the type of data that we are going to be seeing here. So we have this particular data set that adds spam and harm. Legitimate means that the data set is correct, the message is correct, and spam means that the message is from spammers. So the data set has been imported here. So let me show you how the data set is being imported. So let me just clear. Let me delete all of this so that I can show you how it's being. So you can download the data set from Cargo or anywhere. You can click download here. So I've already downloaded the data, but I will just I will just import a new one so that you guys can see how the data set is being imported. So to import data, you can click here. When you click this, we have a model page here. This is a model where you build your model, and this is the data set page where you import your data. So for data set page, you can click on import. When you click on import, you can look for where your data is. So this is my data. I will go and look for my data. I will click upload, or then come to select file. This is a file. I've downloaded the data, and the data has been separated into two types of data. We have our trained data set and our test data set. So I'm importing the two data sets. So I will click open. So I've imported my two data sets here. So I will show you what are the different things that you can do on this particular page. So this is your data set. You can click on the data sets to rename the data sets, or you can click these three data sets to preview the data set. So this is data set. You can see spam. This is what we want to predict, either spam or not spam. This is the SMS. So you can create a model from here. You can click on create a model directly from here. And you can check your second data set, which is going to be your test that you want to be used to test your data. You can preview it. You can see that our test, it doesn't have any prediction yet. It's only the SMS, the type of SMS that we have there. So what you need to do is, okay, you can click on the one that you want to use for your model. And so this is the data set. You can come to the model. When you come to model, you can click on create model here, or come to new model at the top here. Then let's call this spam. Okay, spam SMS prediction model. So this is the title of the particular project that we want to quickly run. So now that I've named my model, so I need to select the data set for my model. You can see my model name is spam SMS prediction model. So I need to select the training data set. This is a training data set. So I will click select data set. You can see that it starts like about 4 steps for me to complete my model, the work I'm working on the model. So now I've selected that. So you see it has shown me the number of columns that my data has. It has SMS test and check. So it showed me the missing data number, if there is a mismatch, if there is a unique number of unique, meaning if the data is a numerical value that can be evaluated with mean and mode. So what I need to do now, select a column to predict. So this particular place is where we are going to select the column that has the variable you want to predict. So I want to predict check. So you see, immediately I select check, it shows that we have ham and spam. So that you know that those are the two things I want to predict. Which is, if you go to my model type, it's already identified my model type. So it shows that I'm predicting 2 category prediction. Your model classified check into 2 categories. See, you can change your model type here if you want to change it to another thing, but it already got it right, so I don't need to change. So then when you are done with that, you can still play around to see. You can remove flow. If you have so many columns, you can uncheck some column. So you can use filter. You can do a lot of things to play with your data as part of your data pre-processing. So you can, if you click on preview model, you will see it will show you the summary accuracy rate of your model. You see estimated accuracy of your model, which is one of the things that we explained the other time. The how well is your model, how well is able to predict, how close to the truth, the percentage of closeness to the truth. Because this model is telling us that the 95% interpretation from the result is true, while 5% is only one that can be due to error. So that's what it's telling us. The model predicts the correct target. It shows that any output that we have from this result is 95% correct. So that is what the model's preview has shown to us. You can click on here to check this is standard build and this is a quick build. So if you want to deploy your model for industry use, that want to connect it to application, is it advisable for you to use standard build so that it will take cognizance of all the it can take close to 2 to 4 hours before the prediction can be completed. But for the for the purpose of this training, I'm just going to use a quick build. Just do a quick build, just for us to see how it works. So I will use a quick build so that I can get the results very faster. So I'll be using, so I will click on quick build. So I will click start quick build. So it's working on my model. So this is so you can see this is the result that we've gotten from our prediction. So you can see impact on prediction. So this is the prediction that we have received. So so if you look at, you can check your scoring. You can check your scoring, how you score some of the. So this is all prediction. This is predicted and this is actual, and this is your model accuracy. You can see model accuracy. So 94% of time, which is about 95% of time. So for the valuable data harm in the data set, the model predicted 99.5% of them to be harmed. So you can check your advanced. You see, this is what we are showing you the other time. So this is your F1 score. You can click here to see the nature of F1 score. This is the meaning of what this particular score means. This is the balance measure of accuracy that take into account class balance. So this is the accuracy out of all the prediction, what percent we are correct. That's what it's telling you. So of all the time that arm was predicted, the prediction was correct 24% of time. You can see it interprets your result for you. The model correctly predicted 99.5% to be harmed when checked was actually harmed. So you can see your AUC. The AUC measure how well your model is able to separate the categories in your data set. 0 to 1, where 1 would be perfect prediction. So these are this is true positive. Out of all of the data, 205 was positive predicted results. So when like a particular the output was positive and was predicted positive, this particular negative means that it was negative, true negative, and it's predicted negative. So these are the one that it got about 12 to be error. So that's what it's telling you. You can download this if you want to download it so that you can save it as part of your report. Maybe you are working on a particular data, you can save it, then you can make use of it in the nearest future, or maybe you are working for a particular project. So now we can see, after knowing all your model status, the next thing is to predict. So we can click here to predict. You can click here to predict. So either of the way is good. So I'm going to click predict. So now to do prediction, you need to select data for your prediction. So I'll be coming back here to select a data. So I've already used my train data set for the other one. So I'll be going to use my test to test. You see, I'm going to use this to test for my on my data that my algorithm has not seen before. So I'm going to use generate. So you can see this. So it's coming up. So it will generate a prediction for us. So this is the prediction. So that generated the prediction. You can do prediction by if you want to do it one by one, or you can do it for all of these. For all the old data sets. So I've done it for all of the old data sets. So these are prediction. You can see the prediction. for each of the SMS type. This is the percentage probability of its accuracy, because it's 99.8% sure that this is spam. It is 8.6% sure that this is spam. So this is your output. You can download it as a CSV, and you can download it as CSV. You can download it as CSV. So it's pretty simple. So let me click on open. So you can look at the. So we can see the output. You can see it here. This is the output. It has predicted that all of the data, the one that has spam. Did you see that film? We know that it's not a spam. If you don't, your price will go to another customer. All this, you see, this particular message is a spam. So it has predicted our data. The prediction has accurately worked for us. So, quick one. Let me show us another example that we can do. Let me show us the customer churn. So let's go to cargo as well. Let's check some data on cargo. Customer churn prediction. So all of these data are on public domain. You can try it. So I know that Congo is a platform to do hackathons and to do a lot of competition. So this particular website, you can be using it to run your model, and you steadily have your. So you can see the type of data that the cargo has on this. We have customer churn. This is the data. You can check your data here. You can see it here. You can see it here. So you can download your data and replicate it. Follow the same principle that was used here. Follow the same principle. So if you want to come back home, click on data set. So this is the data set. So for the purpose of, if you want to do for the image recognition, but you need your data to be compacted. So let me show you a data that's related to image recognition. It's the banknotes. So we want to check if a particular banknote is authentic or it is fake. So these are a typical example of that. So let me go to data model. So let's create a new model. Banknote prediction. So for banknote prediction, so you can import our data. So we already have the data here. So this is a train data. So let me show this. So this is the data from banknotes. So they already converted the image into numbers. The image has been converted into numbers. You can see the clearance of the wing, the skewness of the wing. So the skewness of the wing. So this is the banknotes. These are the images has been converted into numbers so that it can help in prediction. So and this is the class. This is the class of the data. So let me show us how the file look like in the typical so this is a banknote. So this is how it looks. Let me use this. So this is a banknote data set. This banknote data set. This is a skewness of wavelength transform. This is the transform image for people who want to do image recognition. So this is it. This is the kurtosis or wavelength of the transform image. This is entropy of the image. So for every of the, so if you want to be doing image recognition, you have to get familiar to all of these terms. These are the processes that need to be followed. Then the next thing you need to do, let's import our data as we did for the other one. So let's come to, let's select the data to be used. So we are selecting this particular data. Let's select our train data. So the target column for our data is class. So we can see that the true prediction is either it is fake or it is not fake. So we can preview our model just like the way we did for the other model. It's all follow the same procedure. So it will take about seconds. This is it shows that estimated accuracy for prediction on this model is 19%. So we can do our quick build to check to predict the banknote for us. So we need to wait for about 1 to 2 minutes or thereabouts. It depends on the size of your data. So this is the prediction. It has shown to us that these are from the data from the image conversion for the banknotes. Which of them contributed to this prediction? You can see wavelengths, variance of the wavelength transformed image. So these are the initial impact of transformed image. So then you can check your scoring to see your model accuracy. Then you can check your advanced metrics to see your F1 score accuracy and the likes. Then you can come to predict. So when you come to predict, you need to select the data. So you come to select your data, which is this is it, banknote authentication. So I'm selecting you know that it doesn't have any output here. So let's just select this. So generate prediction. So let it roll. So let's check. So this is it here. You see, it has predicted the. So this is the prediction. These are predictions. So let's download it. And look at it as well. Network. Okay. So this is it. So let me show us. Yeah. So now this is the result. This is your predicted. This is your prediction results. This is the prediction results. So you can see your prediction results of which one is fake, which one is not fake for each of the banknotes that you train with your model. So that is that about some of the key highlight on what we can do with no-code AI platform. There are a lot of platforms that you can use to do your predictions. One of them is the Click. One of them is this Click AutoML. Click AutoML as well. They all perform similar. They all have similarity. So it's Click AutoML as well. It's perform the same function. So you can sign up on Click AutoML for free as well. So to do your predictions. So we have various various things that you can do with the model. So you can see that we have a lot of things that we can do with this. So I will send the data to to everybody so that we can all, I think you all have the data on the public domain. You can all download it. But the one I use, I can as well share it for the purpose of people who want to work with that particular data that I've separated into test and train. So I will share that as well with everybody, maybe before we leave this call. So thank you so much for your time. Thank you so much for listening attentively. So let me take your questions.
Okay, David. So we have few questions for you there. We have, can we see the final hyperparameters value? Peradventure, you want to replicate with a non-auto approach. Did you get that?
Okay, so one of the things you can do, so if you want to see that, so when we are building this particular, let me show you one more again. So when you are building your data, so all the hyperparameter tuning and the like, this is where you do that. You can select the variable that you want to use here. Let me check. Okay, let me do it with another, let me come with another data set. Okay, let me work with another data set. Okay. No. Let me check this. Okay. Select data sets. So this is where you, if you want to replicate what you have done with if you want to write a code or the likes, check this is where you do that. Like now, I want to select a particular data. Like if a particular variable is not, so if you select, you can check some these are predicted. This is the variable that we are predicting. So you can select, you can drop, okay, so you can drop any model here. You can drop them by uncheck. If you see that they are not contributing to your model, you can check them here. If you have a missing data, you can filter your missing data. You can click on filter here to remove. You can extract. You can remove them from the analysis. As well, you can remove them by row. You can remove column, remove row. You can remove it here. If there is a particular variable you want to replace, this is a replace button. To do that, you can click a replace. By click, you will choose the particular column. Then you will choose the particular value you want to remove. Is it a missing value you want to remove or the outlier from the data set? So you have a lot of this data cleaning and you can tune anything around this area. So these are just what you have. A lot of things that you can do around it here. You can still explore it to learn more about it.
Thank you, David. Another question for you is, can we use this application for image recognition? I think that's
yes, that was done with the. So you need to convert your image to numbers, then upload it to. You see that one with the sample that we did with bank. This banknote, this banknote is an image. You can see that the data set is an image. You can see the data set is an image. It has been transformed. You can see you need to transform the image to all this numerical value so that you can use it for prediction. You can see variance of the wavelength transform image. These are the banknotes. So when you are done with that, then you upload it to the platform. Then you follow through to make your predictions.
Okay, so the last question that we'll take today is it possible to extract the code and accurate results in CSV?
Yes, that's what we've done. This is the result that we've extracted. maybe the person did not see it when we did that. But this is what we have done exactly. When you are done with your with all your analysis, when you are done, what we did was that we shared the I think I show us how that is being done. Good. Let me come to quick build. You come to start build. So you see this analysis is being done. Then when this analysis is done, you predict, then you download the predicted variable. So only this, if you come to predict, then you select the data that you want to use to predict. You select, when you select your text for the model, you select it. So it's working. So I'm doing it for the purpose of people who did not see it clearly. So this is it here. And this is your predicted values for the analysis. This is the predicted, you can see prediction. This is your prediction that you did. You can download it as CSV. If you are working on cargo, you can upload the prediction to your cargo. You can upload the prediction. This is it here. I'm opening it now. This is the prediction. This is the prediction that we have. This is your prediction. You can upload it to any platform you want to upload it to. You can upload it. These are the predictions that you have. You can delete any column if what you want to see is just the class, the prediction, and any column that you want to see. You can delete the other one that is not necessary. Then you upload it to maybe cargo or anywhere. You can also see that the data that I'm currently used for this analysis is from cargo. I downloaded it from cargo, and I take it into train and test. So it's very simple as that.
So thank you, David, for that awesome section. I want you to appreciate David with your favorite emoji in the chat box. Thank you so much for sharing with us from your wealth of knowledge. So before we go today, okay, thank you, David. Before we go today, I want to quickly talk about data fluency. Please confirm that you can see my screen, please.
Yeah, your screen is up.
Okay, so I quickly want to talk about data fluency platform. You know that data science is big on data. So I want to talk about data fluency platform. This platform helps in evaluating the organization's ability to generate, store, and get maximum value from their data. It also reveals how the organization is faring with data. So if you are interested, I encourage you to scan this QR code on the screen or visit the URL that will be shared in the chat box with you. Also, recommendations will be given based on the results that is gotten from whatever you get there. That being said, we cannot become a machine learning expert in just 3 days. We all know that. So to continue your training on becoming a machine learning expert, I would like you to join our community of professionals by scanning the QR code on the screen or follow the URL that will be dropped in the chat box. I really appreciate you for joining this session. For those that have questions that we could not answer, once you join our Telegram group, drop your questions there and there are people that will pick the questions up. Thank you and enjoy the rest of the evening. We are done for the day. Bye.